We're going to continue on with our simplifying rationals today, and in our second part we're going to look at our different types of factoring and some higher level thinking in order to do our simplifying. Hopefully yesterday we got the general concept and we were able to understand what it takes to be able to reduce these fractions, these rational expressions. So let's go ahead and look at our GCF example to start with. This is what we did yesterday, where you look at a problem such as 8x squared minus 12x equals divided by 12x minus 18. And to start with, I'm going to factor both the top and bottom. This is always going to be our first step. We want to factor out the greatest common factor. On top, I can divide out a 4x, which gives me 2x minus 3 left in the parentheses. On bottom, 12x and 18, I can divide out 6 from both of those, which leaves me with 2x minus 3. Now, you should recognize the common factor. 2x minus 3 shows up on both the top and bottom, so I can divide that out, leaving 4x over 6. And that is not a simplified answer. Hopefully you look at 4x over 6 and realize I can continue on my simplifying because 4/6 is 2/3 and the x stays up top. So my simplified form of that is 2x over 3. And then as always, I need to include my excluded values. My excluded value says what would make the bottom be 0. So if I look at my original bottom, 12x minus 18, and set it equal to 0, I get 12x equals 18, x equals 18/12, which reduces to 3/2. So that means x cannot equal 3/2, because if x were 3/2, the original problem would be 0 on bottom, and that can never happen. So that's going to be our process here. We're going to get into more advanced examples, but we just need to understand that process that says factor, divide out common factors, make sure you state the excluded values. Our second example is going to be factoring trinomials. This is something we have done a very large amount of work on, where if you look at your top, x squared minus 10x plus 16, if you have the trinomial, we're looking for the numbers that go into 16 and add to negative 10. So we get x minus 2 times x minus 8 on top. On bottom, we have a greatest common factor. So we're mixing our factoring trinomials and our greatest common factor. You need to be able to recognize when to use which factoring method. The bottom has 3x squared minus 24x. Well, I can divide 3x out of both of those terms, which leaves me with x minus 8. So now I can simplify. And when I go to simplify that, my x minus 8 is a common factor on top and bottom that can be divided out. And I get x minus 2 over 3x. And we are done at that point with our simplifying. Remember, you cannot do this and get negative 2/3. Remember, that is bad. That will make the baby angry. If you did not watch the video yesterday, that makes no sense. But we do not make the baby angry. So we cannot cancel out those x's because of the minus tying those together. So let's get rid of that. And here's our final simplified answer, x minus 2 over 3x. The next common mistake comes with the excluded value. People right away say, well, x can't be 0, because 3 times 0 would make the bottom be 0. And that's absolutely correct. However, that's not our only excluded value. Our excluded values, we said, always come from the original, or we could look at this form, because this is also the original in factored form. We need to figure out our excluded values before we simplified. So x can't be 0 is one of our two excluded values. Our other one is x can't be 8. Because of this x minus 8 there in parentheses, if x were 8, that would also make the bottom be 0. So your final answer will need to have both of those excluded values. All right, one more example here. And this is just a quick chance to review our advanced factoring. Factoring with a leading coefficient. Remember that number in front changes our factoring. You cannot do traditional factoring of what adds to the middle and multiplies to the last there. Our shortcut for doing this was the AC method. So I'm going to go over here on the side and do my factoring work for the top because I can't just factor it quickly. So I'm going to come over here and I do my 6 times negative 3 is negative 18. I'm looking for numbers that add to 7 and multiply to negative 18. Those are 9 and negative 2. And so those become my new middle term. So I have 6x squared plus 9x minus 7x minus 3. There's our rewritten form using our AC method. And we can factor by grouping. I can divide 3x out of the first pair. Out of the second pair, sorry, that's a negative 2. Out of our second pair, I can't divide out anything from 2 and 3. However, I need my signs to both be positive, so I divide out a negative 1. And we get to our factoring by grouping form, which leaves us with our final factors of 2x plus 3 times 3x minus 1. Factoring with a leading coefficient is more challenging. We've done some of these. They're not going to go away. So we look at our factored form now. My top factors to 2x plus 3 times 3x minus 1. The bottom, out of 9x minus 3, I can divide out a 3, and I get 3x minus 1. I have a common factor. So my answer is 2x plus 3 over 3, where my excluded values, again, I can look at my original or my factored form, either one will get me the same answer. If I have 3x minus 1 equals 0, I add 1, and I divide by 3, x cannot be 1/3. So here's my solution, my factored form, and my excluded value. I need to make sure I have both for every problem. So this is what we're going to do tomorrow. We're going to spend some time factoring and dividing out common factors to simplify.